Why do we feed chemicals to a cooling tower in the first place? This is a very standard setup of a chemical feed system for a cooling tower. Series of 3 to 5 chemical tanks that are dosing a system with scale inhibitors, corrosion inhibitors, and biocides. But why do we feed a cooling tower with chemicals in the first place? The answer is to maximize control of the system from those increased mineral concentrations. As we're evaporating the pure water in a cooling tower, we're not evaporating the minerals in the water. So as those minerals build up and we get exposed to issues like bacteria growth, corrosion, and scale, we need to dose a system with these chemicals to protect the equipment. We feed chemicals to maximize control in a cooling tower system, which is what we consider goal 1A of a cooling tower water treatment program, maximizing the control of scale, corrosion, and bacteria. Scale is the magnesium and calcium ions that are in your water naturally that will precipitate out and cake on your equipment, clogging up chiller tubes, depositing on tower fills, causing issues, and it really impacts your heat transfer. Even in eggshells with thickness of scale is equivalent to a 12% decrease in heat transfer efficiency. So managing your scale in a system is of the utmost importance for energy efficiencies. Corrosion, that's fairly obvious. We want to extend the longevity of the equipment in our system and not have to replace it any more frequent than necessary. And lastly, bacteria. Not only is it a safety concern for things such as Legionnaire's disease, Giardia, it's also a heat transfer inhibitor. Algae growth, which is a very common thing we can see in cooling towers, can be up to 4 times as insulating as scale. So not only is it a safety concern, it's also an energy efficiency concern. That's what we call goal 1A as water treaters. Goal 1B, which we consider just a little less important, because if you're not doing goal 1A, you're not doing your job, but we want to be able to do goal 1A, maximize control, while also minimizing consumption of water, energy, and chemical. Water, if we can operate as high cycles as possible while still maintaining control and reduce our water consumption and disposal. Energy, if we can keep the scale and biofilm in check in a system, optimizing the heat transfer, reducing energy costs, and doing all 5 of these things, maximizing scale, corrosion, and bacteria, minimizing water and energy consumption while using as little to no chemicals as possible. That's the sign of a well-run water treatment program.